condition, the temperature of that day should be more than 45 degree. And to declare is a severe heat wave, it should be more than 47 degree. And these criteria should like fits for at least 2 stations at a subdivision level and at least for 2 days. Then on the second day, it will be declared as a heat wave. So you can see here, heat wave has many fatal impact on human body. You can see as temperature increasing, it can cause fatigue, heat stroke, and also if temperature is more than 50 degree, there is a very high chance that weak people will die, and especially the old age people and who has some medical condition, there is a huge risk on that. So that's why heat wave used to be studied in an extensive way, such that we can predict it in a more better way. And this is a chart for heat index published by NOAA. So you can see not only the temperature, another factor which can also create like heat wave, that is the relative humidity. So as humidity increases, even if temperature is low, such as like here temperature is nearly 30, 35, there also it can be, it can trigger a heat wave on that place. So that's why these two factors are very important, temperature as well as the humidity. So how does a heat wave form? So that is also an important point. So there are lots of complexities are there, but I try to explain as simple as possible. So it's due to the like a stationary high pressure system which creates a cap or kind of an envelope over a area at the upper level, which doesn't allow to go the lower atmospheric warm air to goes up and redistribute in the upper troposphere. So it just blocks that. It's like a block. So here you can see this high pressure system creates a downward sinking motion, and due to which this warm near surface air gets trapped on that umbrella. So hot air gets hotter. So it creates kind of a heat dome. So that's how heat wave forms. So you must have remembered the heat wave condition in Canada recently, where Canada is a very cold country and seasonally it's just filled with ice and snow. But there also temperature reached up to 45, 42 degree, where many people died also due to, and exactly this kind of condition happened during that time. So yeah, you can see the list. Recently, lots of heatwave events are occurring. Even you can see this Paris is also a kind of a nearly cold country. You can see the temperature is 42 degree near Eiffel Tower. People are taking baths publicly. And this is recently from the UK heat wave. So it's a crossing between Petersburg and King's Cross. So there you can see the railway crossing even melting. And heat wave also hits the Arctic Circle very badly. You can see here, it just temperature is so high. Where is Arctic Circle is like always sub-zero temperature, where also seasonally it can hit by heat wave. So it's a major concern. So let's talk about the heat wave in India. Recently, you can see normally heat wave starts in India somewhere in May and starts just before the monsoon, 2-3 months. But this time you see heat wave starts very early in March. It starts, and you can see that most of the states in the northern India or west north India, heat wave hits. Even in Jammu and Kashmir, which is a like kind of a cold place due to its high elevation, there also heat wave hits. So this it was a, and heat wave also creates water scarcity and other problems. Now talk about the marine heat wave. Basically, heat wave, same thing. It's just anomalous warming in the ocean temperature, which affects the marine ecosystem and eco-life. But statistically, it has some little difference with the terrestrial heat wave. So you can see, so when anomalous warming event happened for minimum 5 days or more, so minimum 5 days should be there, which is the more than the 98th percentile of its climatic value. So here is this is the temperature. So it's time. So this blue curve is the climatology, long time, 30 or more than 30 years, long time climatology. So 98th percentile of this climatology is this green line. So whenever for a more than 5-day period, observational temperature is like SST is higher than this threshold, and for the minimum 5 days or more, then we can declare it as a like marine heat wave event. And there also you can see some heat spikes are there, but their periods are very shorter. So that's why they are not considering as the heat wave. And here you can see the severity of heat wave. So this is the climatology. Then the lower this line is the 90th percentile. So twice of it, thrice, fourth. Likewise, each category is like mentioned, like moderate, strong, severe, extreme. And you can see this dotted black line. You can see this SST can reach up to the extreme point. So marine heat wave is also a concern. From Las Vegas, it's very clear. So lots of research has been done in recently regarding the criteria, how to define marine heat wave and all. So mostly, normally ocean temperature is upper ocean temperature is 25 to 30, 32, but sometimes it can exceed, and then like marine heat wave kind of condition may occur. So normally threshold is like 30 degree based on this paper. Then and its anomaly is very important. Actually, it should be more than 3.5 from its climatology. So this is the recent present condition, like for the last month, July condition of marine heat wave. So if it is more than 3.5, it may trigger the marine heat wave. So you can see like this west northern Pacific, then some portion of Arctic, and nearby Antarctica also, Southern Ocean also, marine heat wave, and yeah, Mediterranean Sea. So marine heat wave condition may occur. So this is the observation, and this is the prediction for next 15 days, and initialized at 1st August for 15 days. So you can see the probability is very high, even for Bay of Bengal, Western Indian Ocean, then most of the Pacific, and even in Antarctic also, Atlantic also. And this is the long time series starting from 1990 till today. So this is just the SST anomaly at this position in Pacific. So you can see after 2014 or 15, this trend is like occurrence of marine heat wave is very higher. And these gray bars are just SST anomaly. But whenever this green or maroon or this dark yellow colors are there, which represents the 98th, 95th or 99th percentile value. So you can see from 2014 onwards, occurrence is very high. And even and in 2020 onwards, it's too high. So what are the like, and even in news also, it's everywhere in the news. The adverse effect of heat wave on marine ecology, it's everywhere. So this published in the Hindu. So this is in the Gulf of Mannar, which connects the South China Sea and Andaman Sea. There also coral reef are bleaching here. Then also recently Mediterranean Sea also faced a very huge impact of marine heat wave. So lots of news are there. So what's the driver for marine heat waves? So this is from one paper published in Nature. Sorry, I forgot the citation. So basically here, upper level MZO triggers the Rossby waves, which strike at the tip of the Southern America. Then it goes northward, equatorward, and it meets the subtropical this high, and it just blocked there. Due to this blockage, you can see the very less precipitation is there because winds are very weak, which can like evaporate the high temperature water. So and it's very high short wave is there. So this kind of condition can trigger the like marine heat wave. And this schematic is showing the how it's impact the marine life. So you can see this is a very high atmospheric pressure system, due to which winds are very very weak, which affects the Ekman dynamics, because when there is a very high wind, it will try to deflect the water column towards right in the northern hemisphere, which is basically the Ekman dynamics. So as wind stress are very weak, Ekman transport is also very weak, due to which upwelling is also very weak. So, and as upwelling is weak, so coastal production, marine productivity will be very less, because nutrient will be supplied from the subsurface to the surface for the marine productivity, phytoplankton production. So that's how it's affecting the marine, so marine ecosystem. So it can collapse the, if severe heat wave, marine heat wave is there near the coastal. So now let's talk about the interaction of marine heat wave with the Indian summer monsoon. And basically, I'm following this paper, Saranya et al. Recently published. So they have used a few variables like OISST, Oscar current data, then monthly potential temperature and salinity, and also HICOM reanalysis data to verify the observational results. They also use atmospheric variable for OLR data from AVHSR from NOAA. Also, they use the flux data to check the genesis and atmospheric condition that time when marine heat wave forms over tropical Indian Ocean, and which may affect the Indian summer monsoon. And also to check the how it affects the Indian summer monsoon rainfall, they use IMD rainfall data, daily data. So let's talk about the results. So this is the climatology, long-term climatology of marine heat wave. Based on the criteria, it should be 5 day, more than 90 percentile and all. So based on those criteria, they have just calculated the climatology, annual climatology, or JJS, like monsoon season climatology for the Indian Ocean. So you can see the northern Indian Ocean is heating very fast, and in seasonal scale also, in especially for monsoon time, this northern Arabian Sea and the Bay of Bengal, this is temperature count marine occurrence of marine heat wave per year is very, very high. And this is the climatology, and this is the trend. So here trend you can see for annual time scale. This is the box for Western Indian Ocean box they have selected, where values are very significant. And another box they have selected, this is Northern Bay of Bengal, BOB box. So here you can see the trend is very high at annual scale in the Western Indian box. It's nearly 1.2 to 1.5 events per decade, or 0.12 to 0.15 events per year. And in annual scale, and in seasonal scale, Bay of Bengal has more contribution in terms of occurrence of marine heat wave, which is nearly 0.5 events per decade, or 0.05 event per annum. And this is the month-wise trend. So you can see, and this is averaged over the Western Indian box, this box. And this is averaged over the Bay of Bengal, Northern Bay of Bengal box. So you can see the even in monthly trend also occurrence, the number or frequency of occurrence of marine heat wave is higher throughout the year, especially from February to May, and some relaxation in June, July. Again, in later part of the year also is very high, and is highest in the maximum in the November. But unlike this Western Indian Ocean box, in the Bay of Bengal, is very less from occurrence is very less from January to April, and also in November also it's very less, and it's high is maximum in the August, and it's very higher in the summer monsoon time, and also in December. So and this is just a slope line with this yearly events. So you can see slope is trend, annual trend, even seasonal trend is going upward, which means the occurrence is getting more and more. So yes, this is over Bay of Bengal, right? Yeah, this is over the Western Indian Ocean box. This second column is for Bay of Bengal. And this is they also try to the how it links to the climate modes, the occurrence of the marine heat wave occurrence with the uh, climate modes like ENSO, IOD, then NIO, and another mode also they include, that is the Indian Ocean basin wide warming. So here you can see the, and this is for the annual scale, A and E, and C and Z is for the seasonal time scale. This is just a correlation for the occurrence of marine, like number of marine heat wave days and the SST. So you can see even in seasonal scale also, in the Bay of Bengal and even Western Indian Ocean, this correlation is very high, more than 0.4. And these are the like bars are the number of days in annual scale and in seasonal scale, monsoon timing scale, and these different colors are just occurring representing the combined effect of El Nino, then separate and combined effect of El Nino, NAO, then IOD and IOP. So you can see during the at annual time scale over the Western Indian box. So El Nino is a major player. You can see this is the El Nino. Then also the combined effect of positive NAO, IOD, negative IOD is also positive IOD is also considered here. And but for the Bay of Bengal, the major player is IOB, which is this, and which is followed by some combined effect. Yeah. Yeah, negative NI is also present here. So this is the main gist of the paper. That's how they related the marine heatwave events with the Indian summer monsoon rainfall. So the first column is for Western Indian Ocean box. So here you can see during the, and this is the composite analysis for all the marine heat wave events. So here SST anomaly is anomalously high, followed by the vertical velocity is 0 and negative, and it's the moisture convergence is towards the box. And so which means there is a like ascent of moisture is there. Ascending is there in terms of vertical velocity, and moisture supply is there towards this side. So, and that's why actually these decrease the subcontinental rainfall, so which can be seen here. So its anomalies are in negative during the marine heat wave on the Western Indian Ocean. And for the northern Indian, northern Bay of Bengal, there are two effects. So one is towards the central India from 15° north onwards. Uh, there is a moisture divergence is there. Then this is this a positive. This positive means this is the subsidence of the sinking air. So there is a very negative rainfall anomaly over central India. But over the Western Ghat and the Southern Peninsula, due to the convergence of moisture and the ascent of vertical velocity, so there is a anomalously high positive rainfall anomaly. So that's how they are like concluding that. So during the marine heat waves over Western the Indian Ocean and Northern Bay of Bengal, both Central India is receive like Central India monsoon is like dry monsoon, and but during the Northern Bay of Bengal marine heat waves situations, peninsular and Western Ghat part is anomalously high or moisture. So talk about monsoon so far. So this is the real-time time series for rainfall events till 12 August. So here you see this rainfall is almost nearly normal. There's a slight difference is there, and depressor is 8%. And this is for the different regions like northern, then east northeast. Then in central India, so here east northeast negative in temperature, and other regions are almost higher or like nearly normal. And this is the special extension of rainfall till 12th August. So except the Gangetic Plain and major portion of northeast, the most of the India receive good amount of rainfall. Its anomaly is very high. Thank you.
Question? Do this very high cause any death of fishery issues?
Yeah, there are some reports. Yeah, so few years ago there was a huge marine heat wave near Peru coast. So some major the fisheries just really collapsed for.
Okay. Yeah.
Yes.
So the paper which you have shown me, that
Yeah.
paper, right? So that the intensity increase in the frequency of marine heat waves, they are because that they are defined by the threshold,
Yeah.
right, a single threshold. So that I'm wondering what is the difference between the change in SST, mean SST, and the change in the frequency of the marine heat wave? Because the mean increases, you are going to get higher frequency.
Repeat the question, but I don't think you repeat what you.
Yeah, so Professor Random is asking if mean is increasing, likewise, chances of marine heat wave is increasing. Are you asking the question, right?
Yes, yes.
Yeah, but they have like defined that threshold should be 90 percentile of long-term average. So even if mean is high, but yeah, and it should persist for 5 or more days. Sometimes spikes are there, but those are very short period of time. So they won't consider as a marine heat wave.
Yeah, so the base is high, you are likely to get more days crossing the threshold.
Yeah.
So from the pattern, it doesn't look like there is any difference between the change of the mean versus the change in the frequency.
Okay. So I don't have. They didn't mention properly that thing.
Yeah. Okay, anything from the Jack? Okay, yeah. So this year must is going quite smoothly. So as a matter of fact, it's I would say somewhat dull. There are no breaks, there are no major events. Where is mine? Is that right? Yeah, yeah. That's put a slide show. Yeah, this has already been shown by Kalita. So this is to that one more thing. You can see that in the month of August, 16 days haven't gone by. We are 16% above normal in August. Okay, so August is going pretty well. But what's interesting is today. I just took a thing from Windy at about 2:30 p.m. today, and there are no clouds over India almost. Okay, these are low cloud. Those are there. So I think today's rainfall will be quite low. That's my gut feeling. We go by this picture, unless there's some. Okay. Now, if you look at the forecast made by GFS, very poor. You can see that on many occasions, it forecast was very low. As a matter of fact, what I was interested in 17th August. Sorry, 15th August, the rainfall was observed was twice the predicted, which I think is shocking. So I would like to know anybody can explain how a short-term forecast can go that far wrong. I mean, a factor of 2 over all India, not a local. So this is, and this is exceeded all scales here, not gone well beyond scale. And even otherwise, I can see that the last 5 days, the forecast was not terribly good, except today's is okay. Today's 5 is coming out right. Now let's review. Yeah, I can hear you. Huh?
Is it ensemble GFS ensemble or just the single realization?
I think from what say from that website, I think it is single forecast. But I would like to know what the ensemble says. Yeah. They don't say what that part. I think they only say they say GFS, right? They say GFS. So
yeah,
it's not ensemble. I don't think. You can look at the ensemble and see how much spread is there. Yeah. Now let's compare. See, August definitely is going to be above normal, no question about that. So SkyMet is already wrong. SkyMet said August is 90% below normal, 5% below normal, and so that's not true. Arindam said 2.9% above normal. Even Arindam will be wrong, I think. And Arindam tells me that his forecast actually is for Central India, right? All India, okay. Okay, so I think the way it's going, with another 15 days to go, unless there is a major break, it will be more than 3% above normal. That's my gut feeling. Now, the only issue left in the monsoon is right now 10% above normal. Question is, will September be sufficiently vigorous to make it go into the flood category? That's about 10%. That's the only interesting fact left. And being a La Nina year, I think probability is quite high. Now, let's look at some low pressure system. What's interesting is that most of the season so far, we've gone through 2.5 months. There are only 2 depressions on the west coast of India, which didn't even hit India. Just went sliding past Gujarat. Only in the last 15 days, we got 2 depressions forming Bay of Bengal and entering India, and that contributed a lot of rain the last 3 days. And that was forecast correctly. If you look at the forecast done by both GFS and ECMWF, they got the depression right and its path right. They got it right, okay? But what's going on in the future? Now, this is 12th August, a little old. So this is the forecast for really this week. I would say 13th to 19th. And today is 17th, so already there. Now, this is terrible. GFS is saying rainfall of India is 5 millimeters per day below normal. That's not true, okay? And I was surprised. I thought maybe GFS is a problem. So I looked at ECMWF, equally bad. Now, this completely puzzles me. If what you're talking about is a large scale feature, okay, not some local phenomena, then these models should get it right. So I don't know any reason why or Bay Bengal is showing very high rainfall, but the system is not moving into India. That's the situation. And I also looked at, let's say this is, next week. The week next week, the second week, it will be more like 1926 till the end of August. According to ECMWF, there is a huge, what you call dry band all the way from Gujarat to West Pacific, okay? If that is really true, then we'll have a major decline in rainfall from 1926. Let us see what happens. That is the prediction, but some of models are not doing well in getting this feature correctly. I don't know why. Let's look at prediction from GFS. This is okay. This is cumulative. So only thing to tell you in cumulative is that. Sorry, this is very old. I'll skip this. I'll skip this. Also, I'll get to Let's look at. I'm sorry, all these old stuff. I'm sorry. Let me get to all India rainfall as predicted from 2 different dates, 27th July and 10th August, far apart. Okay, and I would say that prediction that all India rainfall will be around 5% above normal has come out true most of till today almost. Okay, and look at the 10th August prediction. There also is 4% above normal this week, and next week is 7%, and the last week of August is 14%. Okay, that doesn't go well with forecast. The one on the left is 12th to 18th, 1926. You can see that the depression which went across is still raining in western Maharashtra, and it moves north to Rajasthan and Punjab and so on the next week. That's what the forecast says. Okay, and this is the next 2 weeks, which normally is not very reliable, but it continues to claim that Central India will get very high rainfall, and it will. The good news for Uttar Pradesh and Bihar is that it will move into the region which is the most deficient region, Uttar Pradesh and Bihar, east, west, and Bihar. That is what they're saying in the first week of September. So that's again what looking for. Now we are not talking about MJO. MJO was not very strong this year. You can see that the MJO amplitude, one is your normalized amplitude, it has been below 1 most of the time. Okay, and so it didn't play much role. Its role was very limited. When you look at the Ventris forecast, also you can see it's very weak upper level divergence is shown, and in the next 2 weeks there's no real signal from MJO. Okay. This is from NCRWF, which is somewhat more conservative than GFS. They are showing 12th to 18th August, slightly above normal North India. But what I like about NCRWF, they give you the wind. Okay, so they are saying that in the week of 12th to 18th August, that is this week, the jet is weaker in southern India. Okay, and that one can verify. Okay. I'll go to now. This all. I'm sorry. I misunderstood that. Okay. But it's not there here. Okay. So to me, it looks like by the end of August, it will still be above normal. But according to ECMWF, there should be huge deficiency rainfall of 5 million per day over 1 week. If that happens, August will come to normal. But the only issue now left is September. If you look at all the association between Nino 3.4 and September rainfall, it should be above normal. But of course, a lot of scatter. It's not a clean result. And so September also normal this year will be close to 10% above normal. The only issue is either a normal day or a flood day. That's the only issue we need to discuss. Okay, so next week will be Harpreet Kaur. Okay, yeah, thank you. Any questions? Yeah. Huh?
MJO.
Yeah.
I think usually whenever monsoon is strong, MJO tends to be weaker.
Yeah, you're right.
That's what this is.
Yeah, whenever monsoon is normal, over normal, MJO cannot. Yeah, because there are two competing circulatory systems. One at the equator, one off equator. If monsoon is strong, MJO is. Yeah, you're right. But I would like to say the heat lag. I'm not sure anybody talk about it. I would like to know who is does the monsoon weaken and MJO strengthens, or does MJO strengthen monsoon weaken? That's what nobody answered. Maybe tough because they do all this filtering over 30 to 60 days. You cannot, right? That's the whole point of MJO. It is a phenomenon which is a much longer time scale. So one cannot really do the Gaussian effect.
From annual variability, we know that in the years when Indian monsoon is weak, then MJO tends to be stronger. I mean, on an interannual.
Yeah. On a season, you're right. But that is just association, right? That's all. But I would like to know whether one can use it to say that, because remember that if you look at MJO data last about 37 years now, there was 1 year, I remember 85, I recall, while doing some work. Very heavy, strong MJO 85. And the monsoon was below normal, you're right. The highest MJO at that time, monsoon was below normal. Okay, then nothing else from the chat box. We'll close it and meet next week. Okay.